Welcome to Hollow-State Designs VFO Kit Assembly Video. This video is intended to help you create another great Hollow-State project. The Hollow-State Design 40-meter VFO is a simple and easy-to-build kit covering the 7.0 to 7.2 plus portion of the 40-meter amateur band. Everything you need to assemble the kit's in the box. The video is going to take you through the recommended assembly step by step. The kit is supplied with a bill of materials checklist. Make sure all the parts are in the box, usually in plastic bags, and you can identify each part. If something's missing, email me and I'll send it out ASAP. Refer to the layout diagram and schematics supplied in the assembly instructions. The layout of components does not have to be exactly as shown on the diagram. Unlike a typical X circuit board, where everything must fit in its exactly through-hole or SMT location, the spirit of this kit is home brew. I intended it to be built like you would if you were home brewing it from scratch. I'll show you how I did it. The first step is to join the two boards together with the provided aluminum bracket and number 4 nuts and screws. The front panel silk screen goes on the outside. And make sure the nuts go on the inside. You can install CV, the variable capacitor, now or later on in the assembly, but I recommend you do it now. The capacitor is supplied with 3 screws to mount it to the front panel. When installing the unit and until it's finished, keep it fully closed to prevent any damage to the plates. Make sure it turns 180 degrees freely. There are 2 solder lugs attached to the capacitor, one connected to the shaft and one connected to the stationary plates. Solder a short bare wire from the shaft solder lug in the center to the board ground directly under the lug. Bend the leads of the 9-pin socket out as shown. Then carefully place it on the Me-tube socket pad, lining up the pins correctly, and solder all the pins to the pad. Now, I use a couple of different types of socket and pads, and the parts in your kit might be slightly different. Following the locations for the components on the board layout, first glue the tube socket pad using 3 or 4 dabs of glue on the underside. Don't install the 6U8A yet. Make sure you orient the pin numbers as shown in the diagram. Glue the small rectangular pad cut from circuit board in the approximate location shown on the placement diagram. It goes right behind the variable capacitor. It'll be the junction point for 5 different components. Glue the 4 Me pads in the approximate locations shown on the diagram. Make sure the pads that hold the trimmer C2 are spaced the same distance apart as the solder tabs on the capacitor. Here's a little gluing tip. I find it easier to put a small drop of glue on the board and then place the pad or component on the board with needle nose. The kit comes with a plastic nut and screw to hold the toroid in place. The plastic screw keeps the toroid windings from moving and helps maintain frequency stability. Put 2 or 3 small dabs of glue on the nylon nut on sort of the opposite side of the flange and place it where the toroid is going to go at the approximate location shown on the diagram and this photo. Let the glue dry completely. Now you're ready to install the rest of the components. Let's start with a tuned circuit. With needle nose pliers, bend the tabs of the small ceramic variable capacitor C2 out at right angles. Now solder the center conductor of the capacitor to that rectangular pad. Make sure the other 2 leads are on top of the 2 Me pads, but don't solder yet. Solder a short length of bare or insulated wire from the other solder lug on CV to either of the pads with C2 and solder both the wire and C2 to the pad. Now solder the other lead of C2 to the other pad. Install C3, the 100 puff mica capacitor, from the socket pin 2 pad to the rectangular solder pad. Keep both leads short. Install CT, the small yellow variable trimmer capacitor. The capacitor has 3 contacts. The two on the outside are soldered to ground, and the one in the middle should be soldered to the rectangular pad. Orient it as shown on the layout diagram. Solder C1, a 200 puff mica, from the rectangular pad to ground. Now install R1 100K resistor from the socket pad pin 2 to ground. Orient the resistor as shown in the diagram. Install R2, another 100K ohm resistor from socket pad pin 3 to socket pad pin 1. Again, orient the resistor as shown in the diagram. Solder a short wire from socket pad pin 4 to ground. This is one side of the filament circuit. Install C4, a 0.01 microfarad cap from socket pad pin 3 to socket pad pin 4. Now install L1, the toroid you made earlier, on the nylon nut previously glued to the board. Put the screw through the toroid and screw it to the nut. Now don't over-tighten the screw, just enough to make sure it doesn't move. Make sure the tap is pointed toward the back of the board and the two wires are oriented as shown in the placement diagram. The purpose of the screw is to prevent the wire turns from moving. Now connect the leads from the coil. Solder the lead from the end closest to the middle of the board to the rectangular pad. Solder the other lead to ground. Connect a short insulated wire from the center tap of L1. Route it around the tube solder pad and solder it to socket pin 7 as shown. The next step is to solder the two screw terminal blocks to the board as shown in the close-up photo. There are solder pads etched onto the board to solder the terminals. The blocks rely on the solder to hold them in place. The block on the right is for filament current, and the block on the left is for high voltage. There is a rectangular silk screen to show where the block should go. The photo on the left also shows light blue rectangles to indicate the locations of the blocks. Melt a little solder on each of the block's two pins, and melt a little solder on the isolated pad area for the left pin, not the ground. Hold the block in place to solder only the left pin. While holding the block straight and oriented as in the photo, melt the solder on the pin pad. Now this will hold the block in place. If the block's not straight, you can adjust it while remelting the solder. Then solder the other pin, the right pin, to the board ground. Your kit might be supplied with green blocks rather than the blue you see here, but they work the same way. Solder one end of an insulated wire to socket pad pin 5. Solder the other end to the isolated solder pad labeled F above the right terminal screw of the filament power connector. Solder one end of an insulated wire to socket pad pin 1 and solder the other end to one of the two Me pads at the bottom of the board. Solder one end of C6, a 100 puff capacitor, to socket pad pin 9 and the other end to ground, oriented as shown in the diagram. Your kit might have a 47 puff capacitor in place of the 100. Solder one end of R4, 100K resistor, to socket pad pin 9 next to C6, and solder the other end to ground. Solder one end of C5, 100 puff capacitor, between socket pad pin 9 and socket pad pin 7. Solder one end of R5, a 1.2K resistor, to socket pad pin 8 and the other end to ground. Install L2, a 2 millihenry choke, to socket pad pin 6 and the other lead to the upper pad where the wire from pin 1 is connected. Don't solder it yet. Now install J1, the phono connector. Flatten out the 3 solder tabs, then with needle nose pliers, bend about 1/8 of an inch of the tab out, away from the connector. Bend the center contact out straight and cut off the narrow part with dikes. It should look like the photo. Install the phono connector in the lower left corner of the board. While holding it in place on the board, solder one of the tabs to ground. This will hold it in place while you solder the other tab. Form the leads of C7, a 0.01 microfarad cap, so that they reach from socket pad pin 8 to the center conductor of J1. It should route in between C5 and L2 as shown on the diagram. Now, it'd be a good idea to install about a 1/2-inch piece of insulation, stripped from a piece of insulated wire, over the bare lead from pin 8 to prevent a possible short to L2. Install R3, a 4.7K 2-watt resistor. It can fit between the B+ terminal block pad and the 2 Me pads. I installed it flat against the board with one lead cut short and soldered to the exposed pad to the left of the B+ screw terminal. The other end is cut and bent 90 degrees so it makes contact with both Me pads, forming a bridge between the two. Now you can solder the top pad that has 3 connections. If there's not enough room, you can stand it up a bit, like the version you see on the right. Now install Z1, the 150-volt Xenier. The leads from both ends are cut short to allow it to lay flat against the board. Make sure to install it with the banded end toward the junction with R3. Solder the other end to ground. Wait to install C8 before soldering the banded end. Now install C8, the 0.1 microfarad cap. One end is soldered to ground, the other end is soldered to the pad with Z1 and R3. With all the components installed, it's time to install the knob on the CV shaft. The knob has one slotted set screw. With CV fully closed, place the knob so it points to the 7.0 mark on the front panel and tighten the set screw. Finally, install the 6U8A in the 9-pin socket. Congratulations! Now you should have a working 40-meter VFO. Now double check your solder connections and check for any loose wire clippings on the board. It's time to connect it to a power supply. It's designed to be powered from the Hollow-State Designs high voltage power supply kit. The obvious choice. The end. I hope you found this video very helpful. If you have any questions or comments, email me. Glad to help. 73 from KJ7 Uncle Mike.